Hey, so this is our last video in the main series. I may have a couple of other small notes, but in this last video what I want to talk about is what happens if this gamma that we've been talking about in dynamic models is 1, because the same principles don't apply in terms of working through some of the issues in dynamic models. So in our last lecture, we talked about how to look at dynamic models and how to calculate the long-term impact of a change in x, what we were calling this new steady state. And it's clear from the equation that this new steady state is a function of gamma. So here we can see that our long-term change in GDP with a gamma of 0.5 is 2 times 5, which is 10, over that 0.5, which is 20. We can see that as we increase gamma, the long-term increase continues to climb. But what happens as we get to 1? What happens is gamma approaches unity, approaches a unit. This long-term GDP change will diverge. It goes off to infinity, and what we can see in our graph is that it looks like a straight increasing line. And in fact, this is a straight increasing line. It's increasing by 10 every single time. And what we call this is a problem of non-stationarity. Our distribution is not stationary, it's moving. It turns out that if we have a unit root, if gamma is 1, which is also called being a random walk, then this causes a lot of problems in econometrics. Now, this being the very end of a very unique semester where we're trying to tone things down a bit, I'm not going to go into a lot of the details around this, but what I want to say is that any two series that are not stationary, that have that type of movement that we saw, are going to correlate whether or not there's any sort of causal relationship between them. Those spurious correlations that we looked at in our first lecture, while amusing, can cause really difficult problems for econometrics and for trying to do what we've been working on this entire semester in terms of establishing some sort of causal inference. So what we would try to do in working with data that might be stationary is remove some of that stationary problem. We could include a time trend that would take part of that out. We could use first differences. That also is a way to eliminate serial correlation. And I said when we were talking about panel data, I was hopeful that I would be able to sort of tie that in. The idea is if you have a long panel and you're worried about the possibility of serial correlation, first differencing removes that serial correlation, but that's something I'm just going to touch on and mention in the interest of time. And so we were looking at y and thinking about whether or not it's stationary. We also actually should look at x and think about whether x is stationary as well. Whether the average of x changes over time in a predictable way. I am just going to leave it at that. The one thing I will note is that dynamic models cause all types of problems. Not only do we have the problem of potential spurious correlation, but we brought up that correlated error problem, and when we looked at it, it didn't look too bad in that it wasn't biasing our results. Well, if you have a dynamic model, a dynamic process determining y, that correlated error problem will actually now bias your results. It gets worse if you, on top of having autocorrelation, have this dynamic setup to how y is generated and created. Finally, the other problem is, unlike sometimes where if we are including fixed effects and there's no fixed effects, no problem. You know, you get an estimate. If you're including an x variable typically that is unrelated to the other x's and also unrelated to y, no problem. You'll get a beta that's close to 0, hopefully. Here, if you actually don't have this type of dynamic process, but you do include a lag, even when this lag is 0, it will cause bias. It won't just sort of be out in the wash in terms of statistics. It will mess up your results, actually. Like I said, we're just scratching the surface here. A lot we could talk about. You could take courses on this simple topic itself. But the point that I want to get across is that time series analysis is very different from the cross-sectional view that we have, in that there can be this across-time relationship and interdependence that we haven't dealt with in the same way before. But in general, doing this type of analysis is hard. Be careful when you're doing it, and look for these type of issues. Thanks you for a wonderful semester. We'll be in touch, and I hope you're all doing well. Take care.